Okay, welcome back. So we're going to be looking at the period of a pendulum equation. So based on what you guys have done in this lab, we should have realized that the only two things that affect the period of a pendulum, so t, if you look at the equation, you can see this, right? It's going to be length is going to affect it, and it's going to be gravity. Those are the only two things. Mass didn't matter at all. You should have found that when you did this lab, that when you change the masses up over here, the it didn't matter. The period, it should have been really close. It should have been the same, right? Any difference would have really just been to like how fast you were actually hitting the stopwatch. It was probably human error. The other thing that didn't matter that you might not have realized was the amplitude. No matter how high you drop this thing from, it's always going to be the same period. Doesn't matter. Like you could drop it, you could just move it just to the left a little bit. That's going to take just as long to make one full swing as it would if you pulled it up here, which is kind of counterintuitive. Okay, so length and gravity. So it depends on the length of the string, and then it depends on which planet you're on. Those are the only two things. Big need to knows. Don't forget that. So just looking at this equation too, if you want to say, okay, if the length goes up, you can see that it's in the numerator on this side. So if it goes up, then time is going to have to go up too, right? If gravity goes up, so let's say gravity gets bigger, you're on like some giant planet like Jupiter or something. Uh, so G is really big. Well, if you've got a really big number in the denominator, that means you're like dividing by a really big number. That's going to mean that the number that comes out, T, is going to be smaller. So it's, yeah. So big gravity means little period. All right. So then really the rest of this is just using this equation for the most part. So a pendulum is 80 centimeters long. What's the period and frequency of vibration? So just really this one's just plugging it straight in and then knowing that frequency is equal to 1 over t. And I'm going to let you guys look through this one as well. Actually, you know what though? I might show you how to rearrange for gravity because I know this is a tough one for some students. So here it is here, one method. I'll show you over here too how I would rearrange for G. So I would start out with T is equal to 2 pi square root of length over gravity. And I want G on its own. That's the goal here, right? What I would do first, they didn't do that on this one. What I would do first is I would get rid of this 2 pi. So to get rid of that, I'm going to divide both sides by 2 pi. Okay, and then I'm left with T over 2 pi is equal to the square root of L over G. Now the problem is I want G on its own, but the problem is it's kind of like locked up under this square root symbol. It's kind of the way I think about it. So if I want to get rid of the square root symbol, what I have to do is square it, right? Squaring a square root gets rid of it, so I'm going to square it. But I can't just square this side, I have to square both sides. So what I have left when I do that is t squared over 4 pi squared, right? Because the squared here applies to everything inside. And that's going to be equal to just L over G. Now what I would do is I would just move G up to the left side of the equation. So I'm going to move it diagonal. So it's going to go up there. T is going to go down and 4 pi squared is going to go up. So this is going to be 4 pi squared times the L that's already up there divided by T squared. So hopefully that made sense. If it didn't, I would definitely practice because you're going to need to be able to do that. So in a second, I'm going to get you guys to do this one on your own, and then I'm going to pop the answer up at you. This one's going to be really similar to example problem 1. All right, so go ahead and pause it now. Okay, so there's your answers. So take a second, pause if you need to kind of look what I did, but I'm going to move on. The other thing though, the sig digs were a little wrong here, so these should be the sig digs that I have down there because there's only 2 sig digs in the question. Okay, number 2. A pendulum requires 56.74 seconds to swing 20 times. What is the period, frequency, and length of the pendulum? So period here is going to be total time over total swings. So 56.74 seconds divided by 20. So our period is going to be 2.837. So it's going to be 2.84 seconds. And remember, when you're looking at your sig digs, this 20 time thing's the whole number. We don't include that, right? So it is going to be, should be one more sig dig. No, it's going to be 4. Should have left it like that. Okay, so that should be my answer then. Okay, and then frequency, which is 1 over that. So 0.3525 hertz. All right, now the last one, a little bit tougher. We need to figure out what the length of the pendulum is. So we're going to start off with our formula. So T is equal to 2 pi square root of L over G. And I got to find L. Okay, so I'm going to divide both sides by 2 pi. So T over 2 pi is equal to the square root of L over G. I'm going to square both sides. I'm left with T squared over 4 pi squared is equal to L over G. And then last thing, I'm just going to multiply both sides by G. So this is going to be, I'll write it up here. G times T squared over 4 pi squared is equal to L. So then plugging in my numbers, I'll let you guys go ahead and do that. You should end up with 1.9 repeated, or 2.000 meters. All right, last one. On the moon, a simple experiment was done to measure the acceleration of gravity. The period for a 1 meter long pendulum was measured and found to be 4.94 seconds. What's the acceleration due to gravity on the moon? All right. So again, we're going to start off with T is equal to 2 pi times square root of L over G. And now this time I'm looking for G like we did above. So I'm going to divide both sides by 2 pi. So I'm going to have T over 2 pi is equal to square root of L over G. I'm going to square both sides. I've got T squared over 4 pi squared is equal to L over G. And then if you rearrange this just by moving things diagonally. Okay, so if I rearrange this, I end up with G is equal to L times 4 pi squared over T squared. So G is equal to the length of 1 meter times 4 pi squared over, our time was 4.94 seconds, and squared. So G is equal to 1.6 meters per second squared. Okay, so that's it for those ones. So now the last thing, just they're quicker hand-in assignments. So this one shouldn't take you too long. It'll be similar to the ones that we've just done. So that's it for that lesson. I'll see you guys in lesson 25.